So welcome to the video lecture series on Introduction to Computer Networks. This is part 3 of our lecture on the topic of Ethernet LANs. So we'll jump up to the point where we left off. All right. So we were looking at the concept of a MAC address forwarding table and something that the switch needs to know and maintain to be able to forward frames effectively. So to populate the records in the MAC address table, we have the process that we call self-learning. So the idea is that the switch learns which hosts can be reached through different interfaces, and whenever a frame is received, the switch learns this information and populates the record in the table. And the record is in the format of the sender and the location pair in the switch table. So let us assume that host A is going to send out a frame. And in this example, the frame has the source as the MAC address of A and the destination as the MAC address of A prime. So initially, the switch table, or the switch forwarding table, or the MAC address table, it's all the same thing. It is initially empty, and A sends the record out to the switch. So at this point, the switch knows, looking at this frame, that it just received this frame through interface 1, and the source mentioned in the frame is A. So the switch just looks at its table and sees that, okay, now I know that A is connected through my interface number 1, and do I have this record in the table? When it sees that it does not have this record, it puts in this information for future. Next, it checks to see if the destination, which is A prime, if the MAC address table has any information regarding the destination MAC address. In this example, it sees that there are no records which indicate that which interface the switch should be forwarding this frame to be able to send the frame to the destination MAC address A prime. So in this case, we have to go through something else. So let us look at the basic logic for forwarding a frame. So first, when a switch receives a frame, it checks to see if it needs to record the incoming link MAC address. So this is kind of like a byproduct which can help the switch forward packets in future, so that it knows that I can forward a packet to this MAC address through this particular interface. So it records the incoming link with the source MAC address. So if the entry is found for the destination MAC address, that's the next thing that it's done, then the first thing it checks is that, is it the same segment of the network that I need to forward it to? Which means, is it actually the same link? If so, it just then drops the frame. However, if it is seen from the MAC address table that the destination is a different interface and a different segment of the Ethernet LAN, it then forwards the frame on that interface that is indicated by the entry. On the other hand, If the destination MAC address is not found in the MAC address table, what the switch does is that it floods all the interfaces with the same frame, except for the interface on which it actually received the frame. So let's look at an example. So A would like to send out a frame to A prime, and the frame has the source MAC address as A and the destination MAC address as A prime. The initial status of the MAC address table is empty. So when A sends it out to the switch first records the incoming link, which is MAC address of A on interface 1. It's just a bonus information that the switch can gather, right? Next, the switch sees that the destination MAC address is unknown. It does not have anything to show where the destination is located from the current status of the MAC address table. So it will then flood it out to all the other interfaces except interface 1. At a later time, let's say A prime is trying to send out a frame to destination A. So now, the switch first records the incoming link, which is the MAC address of A prime, connected on interface 4. However, right now, from the current status of the switch table, the switch can see that the destination A is reachable through interface 1. So instead of flooding it on all interfaces, it can now selectively send the frame to host A through interface 1. So this switch table, which is configured for every switch in the LAN, the information can be put in two methods. It could be static, which means that the network administrator can manually enter all of the MAC addresses of the hosts and the corresponding interfaces for the switch. So this is a very static configuration, and in case one of the hosts is disconnected and plugged in into another interface, the network would stop functioning properly. The other option is what we call dynamic learning. This is the more preferable approach, where the switch adds the MAC addresses listed in the source MAC address in the frame, and this is more common and efficient in our current working LAN setups. This allows us to have the network to be more dynamic, and also can configure itself whenever a change occurs. For example, if you plug out a host and plug it into somewhere else, the switch can automatically eventually learn the location of that MAC address.